Hello everybody, welcome back. Today we're going to be finishing off the chapter. We're going to be looking at 3.8, which is specialty polynomials. So we're going to investigate some special factoring patterns that occur when we're giving a polynomial. So one of the first ones you may remember is the a plus b all squared. Remember, you square the a, you multiply the a by the b and double it, so 2ab, and then you square the b to get the third term, and it looks like a squared plus 2ab plus b squared. So this is actually one of the special polynomials that we worked on earlier on in the chapter. Okay, so let's look at the first example. So the first example says factoring a perfect square polynomial. So we're going to go in the opposite direction this time before we fail in the product of a perfect square trinomial. So now we're going to go in reverse, and we're going to actually factor this. So we're going to do this, and the method I'm going to use is basically going in the reverse, right? So in order to do that, your coefficient in front of the x squared term has to be a perfect square, which it is. It's a 4. And the c value, the constant at the end, that also has to be a perfect square, which it is, 9. And the b value that is in the middle term, that has to be able to be broken down into half, right? And it works out. So you'll see that to see if the 12 ends up working out. When you verify it, that really shows that that it will work out. So it's pretty neat. So we'll check that out in this example. So let's check it out. So we say it's going to be equal to okay, and we get 2x plus 3 and 2x plus 3. And then we want to verify that, make sure the 12 works. So in order to double check that, remember that second term, the b term, should be twice the product of 2x. So twice the product of 2x multiplied by your third term with the constant. So 2x times 3 is 6x. 6x double is indeed 12x, so it does work. So it does factor as a perfect square trinomial. We know it is because we're doing that section, but you'll have to test it. So, for example, if this was an 11x, 4x squared plus 11x plus 9, then it wouldn't work. So that's why we have to check that out. Okay, so we end up with we can simplify this as a 2x plus 3 written as a perfect square, right? So and we can show it as this is expanded, and we can just condense it to 2x plus 3 elsewhere. Okay. This can also go in the when it's the opposite order, like this, ascending order, 4 minus 20x, 25. So let's check it. So 25 x squared. Take the square root of that, we got 5x squared. Or negative 5x squared, as you're going to see in this example. Take the square root of 4, which is 2, or negative 2. So I'm saying negative because if that b term is negative, then the square roots of these can also be negative. So let's double check that before we start to factor. So we have negative 2 multiplied by negative 5x, which would be negative 10x, and we double that, and indeed we do get the negative 20x. So it does work. Yeah, and so there we're all set. So that's equal to bracket, and it'll be 2 minus 5x, 2 minus 5x. All right, and again, this can be written, that's the expanded form, and we can put it in as 2 minus 5x squared as well. Okay, It says verify by multiplying, so just going in the reverse order just to double check. I mean, we verified in our heads, but they want us to verify, so we'll take the original, right? Or say take the answer, and then we'll do the distributive property, which we learned in some of the previous sections, just to double check. So the 2x gets multiplied by the 2x plus 3, and the 3 gets multiplied by the 2x plus 3. All right. Again, we've already technically done that, but then we get 2x times 2x would give us 4x squared, and then the 2x times 3x gives us plus 6x. 3 times 2x gives us 6x, and 3 times 3 gives us 9. Collect any like terms we may have. The 6x has become 12x, and indeed we get back the original. So that's just a way to verify. I'm not going to verify the second one. You guys can verify it, but it will work out to the same thing. I've double checked that already, but you can verify that when there's some check your understandings that you can try as you're working through there. There is a typo. So that 2 needs to be removed, and it has to be an exponent here. My sincere apologies. So take the 2 that was in front here, and that should have been a square. I don't know how it ended up there, so just be careful with that one. The next one in example 2, it says factor each trinomial and then verify by multiplying the factors. So this one here is just it's one by decomposition. There's no real specialty to it. So I need 2 numbers multiplied together to give me 2 times 3, which is 6, added together to give me -7. It will work. So we do have an x squared and a b squared, so that means the middle terms would have to have one of each, a and a b. So let's see if we can get 2 numbers, and if you guessed it, those 2 numbers are going to be -1, -6. You would be correct. So we rewrite this as 2a squared minus 6ab minus ab, or 1ab if you wish, plus 3b squared. So we're doing decomposition. We learned in 3.6. So remember, you're going to treat these. You're going to factor the common GCF out of these 2, and you get 2a is the GCF, leaving you with a, and then pulling out from the 6, that would leave you with a 3. The a is gone because there was only one a. It leaves you with -3b. Okay, do the same thing here. The only thing that's common in the next 2 here, it would be just the b value. So it's going to be -1b if you wish, or just b, leaving you with a. And then obviously you took a negative out, so it's going to be a -3. So -1 times -3. And then there's a b left there. And of course, what we factor out of both is the same. Or what was left in both is the same. We got to be mindful of that. So remember, the 2 GCFs come together to make the first term. And again, you can drop the 1. 1b and b is the same thing. The common in both are the second factor, and you're finished. Okay, so you may recall that. So this is factoring by decomposition. The next one's done the same way. So I'm going to rewrite that. So we figure 2 numbers multiplied together to give us -20. 10 times -2 would be -20. Added together to give us -1. So it would be 4 and 5, and the 5 would be negative. So this would become -5CD plus 4CD. All right. And then we factor out the GCF of the first 2. So the first GCF, the first two is going to be a 5 and a C. So all you can get out of both is a 5C. Oh, 5C leaves you with 2C minus D, because the 5C comes out, leaves you 2C minus D. And then out of the 4C, D, we can get a 2 out of each and a D out of each. So we get a 2D out, leaves you with 2C. And then if we took a 2D out of there, all you're left here with is D. And of course, both are the same. If not, if they weren't, you did something wrong, because we did figure out there were two numbers multiplied together to give us negative 20. Added together to give us negative 1 was negative 5 and 4. So we put the two GCFs together to make the first one. And then the common in both is the rest, the second factor. And there we are. Okay, so we end up with 5CD plus 2CD. You can verify these by multiplying them out. I'll do one. I'm not going to do both. I'll verify the first one, 2A. So it's going to be 2A multiplied by A minus 3B plus negative B. So plus a negative, I can just put minus B bracket A minus 3B. All right. And that gives us 2A times A, which would be 2A squared, right? 2A squared. And 2A times 3B would be minus 6AB, right? And then the A and the B multiply together to give us minus AB. And the minus B gets multiplied by the minus 3B and becomes plus 3B. And B times B would end up being B squared. And then we can combine like terms in the middle there, the 6AB and the AB, so the negatives, they come together and make it 7AB plus 3B squared, which is the original. I'm not going to verify B. You guys can verify B at a later time. All right. So there's a check your understanding that goes with example 2. So that'll be it for the first video. When we come back, we'll look at the factoring, the difference of squares. From there. So the first two examples, we really did those already earlier on. We're just going the opposite direction. And then we'll look at the factoring the difference of squares next. Okay? In the next section. So we'll see you again in the next video, starting here at factoring the difference of squares.